areas. So with that, I would like to turn it over to Jeremy, who will give you a view. Now we're going to get really practical and go into some use cases. You heard the high level, and we're going to get into what are some practical ways of applying this. And so Jeremy, I'll turn it over to you.
Sure. Thanks, Monali. And that was a great segue. Yeah, so if we really drill down into it, there's a lot of different ways we can use data, and I will be presenting on one of the many different efforts that we're making here at the Indiana Department of Transportation, on this data use and this machine learning aspect. So again, my name's Jeremy McGuffey. I'm the Winter Operations Manager with the Indiana Department of Transportation. Just to give you some details and some background about the agency, we cover about 30,000 lane miles in total. That's all of the highways, U.S. routes, interstates within Indiana. Our fleet of big trucks consists of 1,100 single axle and tandem axle snowplows. Just for scale, you can see here that we have nearly 400,000 tons of salt storage capacity, 1.5 million gallons of brine storage capacity. Those numbers fluctuate a little bit, but that gives you an idea of the potential impact of some of these efficiencies that we can gain. And then also at the bottom here, you can see we have 543 static ITS cameras. That number is constantly growing. We're actually going through a period right now where we're increasing that number almost daily. Hopefully, we will soon have a camera site of all of our interstates, statewide. So right now, those are primarily focused in metropolitan areas. Next slide. Yeah, so what brought us here? So we all kind of, regardless of where you come from, the agency, the business that you're coming from or representing today, I think that we all have some similar problems, right? So data here, we at NDOT, we have a problem of collecting data, right? So I'm going to talk here in a little bit about our AVL program, which is our fleet telematics or GPS technology. We're collecting ridiculous amounts of data with that. And that's really going to be a common theme throughout this presentation. But with AVL alone, it's been a very big challenge for many DOTs as to how we utilize that data and how do we get it to tell us what we need to know to make our operations more efficient. So with that, I'm talking about AVL, so technology, right? That's also a big player in innovations, and then partnerships finally. So with Google Cloud, NDOT, and ClearObject, these partnerships are what help drive that innovation. And from that innovation, we see those safety benefits. We become more efficient, more productive at our jobs. And then lastly, we see those quality-driven innovations that impact the quality of work that we do. So next slide. So I mentioned AVL. AVL stands for Automatic Vehicle Locators. It's a telematics. Essentially, it tracks our vehicles and what our vehicles see and do out on the roadways. So below you can see, I'm not going to go through this entire list, but all of these different data points are captured every few seconds by each of our 1,100 big trucks. That actually comes out to, if we're going full force, that comes out to almost 500 million data points every single day, which is a lot, right? So we have to figure out, instead of just letting that data sit, how do we utilize that data to make us more efficient? How do we use that data to drive operations? Because it's a complete circle. Instead of just using that data to look at reports and then set those reports down and forget about it, how can we use that to come back and drive our decisions? So these are just a couple examples. The big one that we'll be talking about today is actually at the very bottom. It's the camera images. Each truck is constantly taking images of the roadway in front of it. And this is year-round. It's not just during winter operations. So we'll explain a little bit more about that here in just a second. Next slide. So one of the one of the interesting ways that we've used this data so far is a project with the University of Purdue here in Indiana, where we took some of this initial AVL data from the first year of use, and we built out some dashboards. The dashboards were actually already existing dashboards, and they were essentially traffic impact dashboards. And it takes data such as INRIX and data from Google, and it plots out, where we're seeing slowdowns, where we're seeing issues on the interstate, so we can really drill down into, what's causing those. So on the updated dashboard here, we actually added in the AVL data from our trucks, from our fleet. That's actually the blue dots that you see here on the left. And then later on, we actually added some more data from the fleet, which was these blue lines, and that actually represents salt treatments or salt applications from our trucks. So as our trucks are driving down the road, it's on a time slider, so fresh applications are going to be blue, and then it starts to taper off after a while. The way that we can use this data, though, is to determine how our trucks and the salt applications are impacting traffic. Are there areas that aren't being touched? Are there areas that need more attention? And how is that impacting traffic speeds and in general the motoring public? Next slide. So one way that we came up with this idea. I peer reviewed a paper for the Transportation Research Board a couple years ago. This was before NDOT even had our AVL installed, and the paper had to do with all this data that's coming in from AVL, and as I mentioned, we're getting nearly 500 million a day. How do we best utilize that? That seems to be a common struggle amongst states or local agencies that have these AVL systems installed. This is one of the many ideas that we had come up with, was taking these camera images from the trucks and potentially the rest of the data, such as spreader data, and using that and putting it through a machine learning environment that can analyze the road conditions from these dash cams and provide us some more insight. With 1,100 trucks, it's hard to keep track of what everybody's doing out there, and for supervisors, it's extremely difficult in real time to make these operational decisions and move your trucks to the right roadways at the right times to make sure that we're getting coverage across our entire network of 30,000 lane miles. So the idea was to have this machine learning platform analyze these camera images and alert our supervisors to where these issues are. Which roads are clear, which roads need attention, which roads are completely covered. And as you can see here, this is just a mock-up of kind of my idea as to how we could accomplish this. Next slide. So we worked together over the period of a few months with Clear Object to actually build these models. We ran because we were getting so many data points, we ran a smaller model in the Indianapolis metropolitan area, where Clear Object had built this machine learning environment. They absorbed a bunch of our camera images in this area, and as you can see, the results speak for themselves. So the graph here actually indicates that the more images we fed through the model, the more accurate it became. Not only with its precision, but also the recall for the images themselves. The camera images were able to identify accurately different road conditions. And I can only imagine, as we feed more through there, and as we move into a next phase with this project, that we can get even closer to 100% accuracy. And I think we can accurately say that we'll never reach 100%. We can get to 99.9%, but that's going to be perfect for us to be able to improve our operations, let supervisors know what's going on the road out there, to improve our situational awareness.